Hello everybody, this is day 3 of the anvil build. You've been following along. Last week I just ran into a bunch of trouble and got kind of fed up with this and had to walk away. But today I have a new plan. I'm going to take this 4140 tool steel and weld it to the top here, and hopefully that solves some of our problems. But if you guys know about tool steel, it comes to your shop annealed so that you can machine it easily and work with it, and then at the very end you're supposed to heat treat and temper it back to the hardness that you want. Welding rod, weld metal is not hardenable, which makes a lot of sense because it has a low carbon content, and as you're welding you don't want everything to harden up and become super brittle. That's why NR211 got discontinued as a structural steel filler rod, because it was too hard and too brittle. So they understandably keep the carbon content pretty low in filler metals. But this is a different story here with this tool steel. It has a higher carbon content. The minimum for hardening, from what I can find, is 1% carbon. MIG filler metal has about 0.3%, and I'm not even sure what this has, but it's above 1% and it is hardenable. So as an annealed product, we need to do a little bit of preheating before we weld, to get this to flow really nice into this. But if you also remember last week, we didn't stop at the MIG wire. We ended up putting some hard facing rod on here that gave us a bunch of cracks and inclusions and a big mess, basically. So I filled it back up with MIG wire and flushed it back down. So now we've got a pretty nice top. But the interesting thing, last week I did the bounce test with this mix of hard face rod and MIG wire, and it didn't bounce very high. It bounced basically the same as the MIG all by itself. I came back to this a couple days later after it had cooled down, and this stuff is super bouncy. It's actually really impressive. I wish we could just stop right here, but the cracking makes this like, it just makes me too nervous to use it, because there's all these little hairline cracks in here. I just feel like it's gonna start to explode and blow up in my face as I start beating on it. But just to show you guys how bouncy this sucker is, check this out. Freaking bouncy, right? Okay, and then up here, we got the same kind of mix of hard facing material and MIG stuff. Well, I can't get a good bounce out here. So this will be the real test. This I don't really have a good solution for, right up here on the face. So this is gonna stay that mix of our hard facing rod, which I still have outside, and MIG wire. So we'll see kind of how this holds up over time, because I don't really have any sort of coating or top plate to put over here. Yeah, let me get a close up here. I'll show you some of the cracking and stuff we're dealing with. So you guys see that crack forming right underneath? You know, that's about where the hard facing rod starts. It's just cracking and splitting away. So it's really not going to give me a great surface to be beating on. You know, you kind of see, that might be undercut, honestly, but it could be a crack. See this cracking showing up right over here. Another little hairline crack, crack. You know, I preheated that hard facing, or I preheated this before I hard faced it. It's just not made to overlap passes like that and stack up. Just too hard. Maybe if I would have like cooled it or wrapped it in leathers, kind of like welding cast iron, and controlled the cool down, may not have had such a bad cracking. Or maybe put it in the oven and slowly turn it down. But I didn't do that, and that takes a lot of time. So this is where we're at. Let's see how this goes, guys. All right, so if you notice, I already beveled or chamfered all 4 sides of this. This plate here actually overhangs a little bit on every side, so I'm not gonna bevel it, but I do have a bit of a belly on top of this anvil right now. See, I kind of rock this back and forth. So what I'm gonna do is I'm going to clamp this side down hard and make this kind of lift up a little bit like it does, and tack 2 corners And then I'm gonna do what's called a hot tack, where I actually tack this, and while it's still hot and cooling down and trying to contract on its own, I'm gonna beat it with a beater, and then it'll hold that tension basically. So we're gonna kind of spring this piece of tool steel on top of here to try and really transfer that load through that plate into the anvil, and that's gonna help us get bounce. Any sort of space or gap or like clicking we have in there, if this top plate can move, it's gonna take energy out. It's gonna act like a shock absorber, and it's not gonna give it back to your hammer. That kind of defeats the purpose of making a good anvil. You want it to be bouncy, so you don't have to work that hard, basically. So I got the propane torch set up over here. We'll do a little preheat, and before I start welding, I'm gonna move that propane tank way out of here. So give me just a minute. All right, we got the sucker preheated about 280, 300, and just gonna check and make sure it's straight still. There we go. All right, now the old hot tackarooski. You want to have your beater totally ready. Oh man, both those cracked as I was beating on them. So let's try that again. Looks like it's holding now. Try this other corner. Nice. All right, I'm running 28.5 volts, about 520 inches a minute, and using 75-25, yeah, shielding gas. Still starving for wire, so I'm probably gonna end up doing a cover pass here. Let me show you guys. See how we got that undercut all the way down? So I got plenty of heat on this root pass. And I'll do a root all around. Then I might turn the heat down and do a cover. All right, now I'm gonna step it down. Oh, weird. Weird! This hard facing is messing with me, dude. It's cracking. Look at this weld right here. Just laid that sucker in there and there's a fresh crack all the way down the middle of it. That's that hard facing rod in there that's just shrinking at a different rate. So that's really the big reason why, where is it? Where I'm going with this big chunk of steel on top. I feel a lot better beating on that over time. 26.5 volts, 430 inches a minute. And let's see if we can fix this crackosis. A little crack here on my stop. I'll show you this real quick. Why not? I don't know if you can see this, but there's a little crack opening up right there in the center where I stopped. It's trying to crack so bad. I really should have hung out there for another minute. So I'm gonna try and fill that back up. But then I'm gonna chase the rest of this all the way around and do a covered pass and build it all up. We need to get this piece of steel hard. Too hard, actually, is where we're gonna get it. We're gonna get it so hard, it's gonna be more brittle than that hard facing rod underneath here that's cracking all over the place. Then we need to temper that hardness and get it back down into like a middle zone. So basically, hardness wise, we're gonna go here, but because it's so brittle, the strength I think ends up somewhere right around here because it just breaks and crumbles apart. So once you get it really hard, you need to temper it and basically realign the crystalline structure of the steel. I'm not a scientist. I studied economics, all right? But basically we need to go from this super hard level and pretty weak right here down the hardness scale, which gets the strength up, and at some point they meet in the middle. And that is where we want to get to, is pretty hard, not too hard, no longer soft, but kind of soft. Does that make any sense to you? Me either. Metalwork is dark magic. We need to get this thing to about 1500, 1600 degrees up here on this top plate. Then dip it into a bath of oil that I put together out of an old pressure pot. Then we take it out of that oil. It's super hard, ready for hard stuff, but not much beating because it'll break. And then we're gonna put it in our powder coat oven, which is the closest thing I have to a tempering oven. And we're gonna try and get it to, I gotta look it up, but I think it's like 400, 500, somewhere in there. Anywhere between like 400 and 800, it seems like will work. And depending on what temperature you pick, kind of dictates the performance of this thing right here. Yeah, heat, quench, bake in the oven for a couple hours at like 400 or 500 degrees. Then we should have something, the right amount of hardness, the right amount of softness, perfect for beating on, super bouncy, and ready to actually make some stuff on this anvil instead of just making this freaking anvil. But as a baseline, let's do a test and see where we're at with our 1-inch ball on this tool steel before we do anything to it, because you already see it's kind of turning this purpley straw color, I think the metal heads call this. Okay. 10-inch steel ball drop. Oh, we lost our hardness. Yeah, this temperer better do something to this tool steel, because so far I am not impressed. It's pretty much the same performance as just the straight up MIG welding. So let's see what happens when we temper this thing. Also, note here, this is already dimpling this plate here before we harden it. So just like the MIG wire down underneath, there's little tiny dimples where this ball struck just from 10 inches up. So this still appears to be pretty soft. In order to quench this, I need to add a hook. So I'm just gonna weld that sucker on right about here, I think. Flare up. Good splash. But that should do it right there, right? Let's go set up for heat and quench. This is taking way too long. I'm gonna go grab the rosebud torch, see if that gets us there faster. All right. Hopefully you guys caught all that. It happened, it felt like it happened really fast, but it took forever to heat that thing up. But as soon as it got up to temperature, it was kind of a race to get it in there. I didn't quite get the whole thing up to 1525 is what I was going for. I got it up to like 1430, and then in some spots I got up to like 1550 with that temp probe. So I was a little shy. Probably need like a proper forge to really heat this up and do it how it ought to be. Filthy. For our purposes, that's going to be good enough. It is just about cooled down in there. Next step, let's take you over. Doo-doo-doo. Can you see this big bad mamma jamma back here? This is our 12-foot long gas powered powder coat oven. That's the best thing I have for temperature. Where's the light? Where's the light? Where's the light? So this oven right back here is the best thing I have for temperature control. I'm gonna load it up in there, I think at 400. I'm gonna double check before I do it and let it cook for a couple hours, and that should temper it back out. It should be super hard right now. You know what we're gonna do? Once it cools off, before it goes in there, when it's at its ultra hardness, let's go and do the bounce test and see how bouncy it is. Before we stick it in there, then we can see how bouncy it is after, and then that's some proper science shit right there. All right, this has been sitting in here for what, like a good 5 minutes? And it heated up that oil to 400 degrees. That's, let's see, 1, 2, 3, 4, 5, 6, 7 gallons of oil that was basically at 50 degrees. That sucker's hot still. Let's go set it up. I know why people love forging so much. Makes your garage smell like a frickin' donut shop with this canola oil. It's still hot though. Don't put your face on it. But let's check hardness real quick before we go and shove this in the oven and temper it. So we've hardened it. We got it up to about 1500-ish, or, you know, plus or minus 100 degrees. Let's see where we're at. So the 1-inch ball bearing from 10 inches. Woo! We got some of our bounciness back. That's pretty good. Nice. And then up here on the horn. Yeah, dead. I can't really see that well, but it looks like we're about 50%-ish. What do you think?
About 8 inches or so.
8 inches? Country's over here telling me 8. I'm gonna check the tank. If he's wrong, he's buying me lunch. And I don't really see it leaving any dents anymore. All right, here's the setup. We got this hung in our powder coat rack. I've got it at the same level as the temperature probe right here. This is what actually runs the heat control for the oven and signals the burners to come off and on. So that's our best bet at having steady temperature. That being said, this is not a tempering oven. This is a powder coat oven, so there are some swings in temperature. It's not ideal, but it's the best we have. So let's roll with it. And I imagine it's pretty similar to, let's say, like your home oven type of performance. And what we're going for is 400. All right, we'll let that sucker cook. Had this thing cooking in here for a couple hours now. So I think this is about as good as it's gonna get. toasty. So honestly, about 350. All right, we'll let this sucker cool down for a little bit. Then we'll get it over to the bench, see how bouncy it is. Guys, I'm not gonna lie, I'm kind of excited at this point. I've been working on this for 3 weeks now, and I finally feel like I have an anvil. I can honestly say this is gonna perform like an anvil. 100% sure about from here forward. But this right here, I think we got it nailed. Which then leads me to the question, was it worth it? And to that, I have to say, absolutely. If you're gonna learn as much as I did through this process. I have learned more about metallurgy and weld metals than I have since I was an apprentice in the ironworkers probably. This just led me to ask a lot of questions that I hadn't asked before, and since I started this video series, I felt the need to finish it. So I spent more time than I should have, I spent more money than I should have, and this is probably not as good as a really nice antique anvil or one made by somebody who knows what they're doing. But I really believe this is an anvil that's going to be in my shop for the next 50 years. And I will find a use for it. And there's always a need to have something solid to beat on in a shop. So without further ado, let me do the final bounce test on this thing. It's still warm. It hasn't cooled all the way down yet. Hopefully that doesn't affect bounciness too much. From 10 inches. That was pretty nice, but I think it got the tape a little bit. Woo! That's a good spot right there. All right, let's see if I have a ball peen hammer. What's better than this? All right, guys, I'm gonna cut this little chicken neck thing off of here and find a spot to park this thing. Happy making, hit subscribe, check us out on the website, makertable.com, and yeah, shoot a comment below. What did you guys think? I have no idea what I'm doing, but my take on this whole YouTube thing is I just want to be like a first grader teaching kindergarten. I'm not an expert, but there's really no need to be nervous about getting in the shop and making a mistake or doing something stupid, because inevitably you're gonna learn something you didn't know before. So really happy making, guys. Catch you on the next one.